Hey, so we're going to be comparing two projectors here, the MLed 1.0 and the MLed 2.0, just recently released. This is a upgraded version of this guy. So basically what we're going to do is we're going to pull them both apart and try undo all the screws we can undo and pull the components out. That way we can see, what's changed, what they're both made out of, differences, similarities, and, ultimately determine if you got these guys installed now, is it worth it to upgrade to these guys, or, is it the same product in a different packaging? So let's take a look. So the original MLed 1.0, and as soon as we open the box, we can see we have our driver box, high-low beam inputs, an actual projector itself. Set that aside. Very nice packaging, I must say. Helps to keep everything safe in transit. The UPS guy kind of have a fun time with that and not worry about destroying it. So projector itself, and then the external driver. Okay, and it looks like we got lock rings, an H4 adapter, and a rubber washer, which is nice. Just some hardware if you decide to do the threaded mount. Let's pop the new 2.0 out of the box here. A little bit different packaging. Same protective material, which is nice to see. And right away we got the H4 adapter and the lock ring. Famous instruction pamphlet that we love to throw on the ground. Some plastic protecting the lens, that's kind of a nice touch. No bag, but it is quite a nice form-fitted foam packaging here, so I wouldn't worry too much about damage to the projector. This packaging is really nice. And then we have the driver itself. And finally, the threaded shaft, which bolts on the back. This is optional. You don't have to install this if you are using the brackets with a nut and bolt method. You do not need to use this guy. So this is optional. It looks like it just bolts on here with a couple screws. And then if you do a retrofit, you can use the original bulb hole to thread the shaft through, put a lock nut on, if you're not using the nut and bolt method. But let's not get too caught up on that. Okay, so I think we can set the hardware aside. It's pretty straightforward. Get that out of the way. Okay, let's set them side by side here and see what we're dealing with. It's a little tricky to get that out. Okay, so right away, first thing I notice here is the drivers are completely different. This one here, nice little MLed 2, actually a part of the driver. This one's just printed on. We have our standard high and low beam input, and same thing for this guy. And that's all very well. Same standard 9005 connectors. No braided wire covering on these guys. But it is kind of a good thing. Basically, these things come with a wire seal that is going to pass through the your headlight housing. With these seals, we find that water does follow the braiding and gets in there, and it can travel past this grommet. Not really the best scenario to be in, especially if your wires go upwards when they're installed. Water's just going to follow that braiding and go right past that grommet and ultimately inside of your headlight housing, which you don't want. This is a much better seal. As we can see, it's very tight, and the chances, even if the wires do go upwards, the chances of water following that wire and ending up in your housing are a lot more slim compared to this setup here. So right away, that's an upgrade. To me, that's an upgrade. It's just small things like that we like to see. So the drivers, obviously we can't pull these apart and take a look at what's inside, but we would assume that these have some upgrades to them. And the projector bodies themselves, just by looking at it, these have a nice plastic trim piece here. It looks like it's just decorative. Nice MLED cut into the side there. This one does not have that. Oh yes, it does actually. It has on this side. This one has on both sides. Okay. This threaded shaft is installed here, but you know, this one came removed, so same idea. Let's get into pulling these guys apart. So another nice thing that I noticed with this projector, the new one, is it uses all the same size bolts. So you have a couple bolts here holding this projector lens piece on, a couple bolts here holding this trim piece on. You know, bolts holding the side wiring, even the bolts holding the fan, they're all the same size head, which is nice. You know, so it makes it a lot easier to remove. This guy's kind of a nightmare because it has one size here, different size here holding that in, and then it has Phillips screw heads holding the fan. So you know, you need your multi-tool to pull this guy apart, whereas this guy you just need the one. So it's kind of nice too. You know, like I said earlier, the small things definitely matter. So let's rip this new guy apart first, and I believe this is just a trim piece on the top here. Just gonna throw all my hardware into this box so we don't lose it. Okay, so yeah, this is just a decorative trim piece. Has a little MLED signature inside there on both sides. It's kind of interesting. It's kind of strange how they put it on the inside. Not sure what purpose that serves, but just decorative. That serves absolutely no function at all. And this is the top reflector. This pops right off. Nice shiny surface there. Okay, and then we obviously expose the LED. It looks like there's some kind of other type of reflector here, and that must just help push a little bit of extra light out, I would assume. So it's right around this LED here. And definitely that's the first thing the light's going to hit. So this must serve some kind of extra purpose because we don't see that on this guy. Okay, so we got that off. And again, we're looking inside of this projector, and they used all the same size screw heads, so that's really nice. You know, if you want to play around with this guy, pull it apart, you just need the one screwdriver. You don't need your multi-tool, which we're going to get into in a second here. Also, another thing I noticed is they used a motor for this shield. So it's an actual motor by the looks of things here. The old projectors, even the D2S 5.0 use a solenoid. So it's kind of interesting to see that they used a motor with this guy. Yeah, that's definitely a motor. Let's pull that off. And again, we got the same size screw head. I love it. Pull those out of there. Get that guy out of there. Tricky, tricky. Yeah, there we go. Okay, yeah, that's definitely a motor, and it's got a little gear here that activates your shield. I don't know if you can see that really well. Actually, let's just pull this lens right off of here too. It'd be helpful if I had a little longer bit, but we'll just be careful not to strip it too bad. Okay. Throw that in there, and we got the lens. Set that aside. Come on out of there. There we go. Okay. Got the lens off. Looks like the bolt-on bracket assembly here comes off as well. So let's just actually pull that off of there also. Exposing this motor. So yeah, we can see that the motor sits here, and when it gets power, it engages and pulls a shield inside here. And that shield effectively is your mechanical high beam. The release of this shield gives you a greater projection than when it's up, whereas this is a effective cutoff line, so you're not blinding oncoming traffic. But when the shield drops, you know, you got your full projection of light, so that essentially is your high beam. So if we look at the driver here, couple of inputs here. We got low beam and high beam. So high beam would effectively power this shutter here and drop that. And it might also light that chip up. So let's just actually test that right now. I'll just plug that guy in there. And I got my power supply, 12 volts to the high beam. There we go. Okay, and that is the correct polarity, and geez, that is bright. So I'm just gonna face this away just so we don't get blinded. Forgot my sunglasses at home. And yeah, we can see that motor turning pretty quickly. And yeah, so as soon as this gets power, that motor turns this shield here, just as we mentioned, and opens it. So you got your high beam, mechanical high beam. It's kind of interesting that they used a motor for this. You know, all the old projectors use a solenoid. It's basically just a really, really long wrap of copper wire, and it creates a magnet and it pulls a pin through, which then activates a shield. I'll show you in a second in this guy. You know, they used a motor on this. It's kind of strange, but hey, it's different. I have not seen that before in a projector. We got obviously our LED light source here, some ribbon cabling going off to the side, and these are all of our controls. Obviously we got our motor here. This one looks like it goes to the fan, and then this is essentially our main input where our power comes through, and our low and high beam. Okay, and then on the bottom we got our fan. You know, let's just pull this fan off and take a look at it. More screws for the box. Oh, it looks like we got some plastic washers that were in between the metal and the fan itself. Okay, so we can see all our cooling fins here for heat dissipation. When you look at this guy, they got quite a bit of big fins here, and this has such a small amount of fins compared to this one anyways. We do see though that it has quite a larger fan that they use, so that must be how they get away with using less heat fins. I guess overall reducing the footprint of the projector just by a slight amount, nothing crazy. So yeah, that's our fan that cools the unit. And these LED units do get quite hot, so you know, heat is the enemy with LEDs. And you know, bigger fans, bigger fins here to dissipate that heat. So it all adds up and it all helps out in the long run. So you know, any cooling is good cooling, especially when it comes with LEDs. So we're gonna set this guy aside here. We're gonna tear into this guy now. And I'm going to use this box just to keep all my screws for this guy. Unfortunately, like I mentioned earlier, they use all kinds of different Torx ends here. We got, you know, one size here, and then we got their Phillips. Actually, make sure I have a Phillips bit handy. Yes, I do. So let's tear into this guy. Use the smaller one first, and we're going to remove the top reflector plate to expose everything inside. Got my glove caught in there, that's not good. That is the one downside of using rubber gloves and a drill. Okay, and we're back in action. So this is off. It looks like this is stopping this plate from being taken off. So let's attack that guy next. And we got our bigger one. That's that one. So, you know, already we can see the inconvenience here of having a bunch of different screw sizes. It's kind of annoying switching between multiple screwdrivers and stuff. Okay, so there's our reflector plate. This is the MLED 1.0. Also, just so you know, this is the original, so we're going over the original. We can see same idea as this other guy, slightly different actually, but it does not have that extra piece that the new 2.0 has. So, you know, it doesn't have that there. I'm sure that this boosts our output or our width to some effect. So, and the 1.0 does not have that. It's definitely something they've added on and improved on. Good to see that. I did a little bit different chip as well, different chip type. If we look at this guy here, you can see the difference. So two different chip types. I'm not exactly sure what type of chip they used here. We're gonna have to look that up and you know, find that out. But let's remove the projector lens without mutilating our glove this time. Okay, more screws for the box. Okay. And yeah, as we can see here, yeah, this is the solenoid I mentioned earlier. It just has that little pin. So when we run power through this, creates a magnet, pulls this pin through, and it activates our shield here. This is our mechanical high beam on the 1.0 projector. And we can kind of demonstrate that as well, just to, you know, seeing is believing sometimes. So let's just light that baby up here. We got our high beam and our power supply. And yeah, we can see as soon as we give power to this guy, you know, it creates a magnet and it pulls that little piston in and it activates our high beam shutter. Okay, so this is the same type of device they use for the high beams on all of the projectors, you know, the MLED, also the D2S 5.0, you know, all Mini H1 projectors that I've seen use this. This is the first time I'm actually seeing a motor being used for that, so it's kind of interesting. Kind of fun. Okay, and another thing to note here, actually, when we put power to the high beam, just this activates. Our LED does not light up. So LED and high beam shutter lights up here just when you put power to the high beam. This one here, you do need power to the low beam for it to work. And the only function this gives you is that shutter. So that's kind of interesting there. Interesting thing to note. Okay, and we got our fan here. It looks like, yeah, okay, so they split the inputs to this side. When we're comparing this here, they just use the one ribbon cable and it all comes off the one side. This one here, they split the input and the fan and the power for that solenoid to the other side. With this rather large PCB board, you know, this is a lot more simpler, especially with this. I'd say that's a lot more modern. You know, less parts sometimes is better. And yeah, let's pull this fan off here. So now we got a Phillips, you know, we're kind of juggling around here with our multi-tool that has power. Let's pull these guys off of here. Well, again, without ripping my glove off. Okay. Also interesting, this fan was held on with 2 screws. The new MLED 2.0 and the original version, you know, they got 4 in here. They got to make sure that fan is going to be in there. It's not coming out. 4 screws holding this baby, and it's probably half the size too. It's kind of funny that they really made sure this fan is in there. Okay, yeah, so right away we're looking at these two. That's a huge difference in size. That is almost double the size fan. So I think it makes up for it with the larger heat sinks, obviously. This is going to help dissipate the heat a lot more. Whereas, you know, our heat sink here, a lot smaller. The fins are very small. The overall footprint is small. It's lighter. This is got quite a bit of weight to it. This is, you know, light as a feather. So they made it up with it with a larger fan, I would assume. And yeah, we can kind of see that. Okay, so the next thing I want to do, I want to light these things up and take a reading, you know, just showing the raw output from the new MLED 2.0 and the 1.0, and you know, face the light meter right in front of it and just get a dead reading, a raw reading of the chips, both of them lit up, and kind of get an idea of the difference in output from these 2 chips. If there is a difference, you know, they look different. I don't know the details on them, but I would assume that they're a little bit different. So we're gonna face them away from us because, like I said, I forgot my sunglasses, and these things are really bright. They definitely blind you. Put power to the low beam here. Okay, our fan's gonna go crazy there. That's fine. And let's get this guy over here. We got the low beam right here. Okay, so I'm gonna face that kind of in the different direction so we don't have any interference. Low beam. Power to the low beam. And yeah, just from lighting these things up, this fan is really loud, and it's big and loud and large in charge. This fan's so small I didn't even notice it turn on. You know, you can clearly hear this guy spinning away. Yeah, there's a big difference in fan size here between the two. Just by looking at the output, the Kelvin temperature is about the exact same. This guy does visibly look a little bit brighter, but we're going to put a light meter in front of them both and kind of see, you know, the truth here about the output. Are they brighter? Are they the same? I would hope that this is an increase in light, but you know, this is going to tell us exactly the full story. So you got K lux, and this is the largest scale because we're going to be right in front of this thing. This number is going to be really big, so we just drop that scale right down. Okay, so right in front of it, the MLED 1.0. We're bouncing around here, but we're getting, I'd say, about 140 K lux right in front of the projector here. So that's 140 K lux. And this guy here, jump right in front of it here. There we go. And yeah, we got 99 K lux. So this one actually isn't quite as bright. It's jumping up to 101 now. You know, it's kind of moving around. I believe these things are regulated as well with the driver. Okay, so this guy is coming from 109 to 112. So the MLED 1.0 is a little bit brighter. Just right in front of it, measuring the raw output. You know, it's bouncing around from 120, 110. This guy here, yeah, 110 now, 111. I believe the way that these work is they monitor the temperature and they adjust the output depending on how hot they're getting. And we kind of have them torn apart right now. The fans are off the unit. But yeah, they're about the same. The MLED 1.0 is giving us a little bit brighter of a reading, However, this one here does have some additional technology added on here to give that added reflectiveness, and I would assume width as well. So that's essentially what we've got here. Just comparing the two side by side. Kind of interesting. Some different components used. The lenses themselves, just by looking at them straight on, they do look about the same. Yeah, they're about the same. Obviously the holder is a little bit different, but nothing's changed there. The distance from the bracket is about the exact same. And you know, looking at the back here, same idea for that added bolt-on thread. You know, that's optional as well if you do decide to mount them that method, or if you want to use the bracketed screws with a nut and bolt method, you know, that's the preferred way. But yeah, that's kind of a quick little overview of what kind of parts we got involved here. So thanks for watching. It's kind of interesting to see, you know, what goes into the products we're buying, and yeah, you see it right here.